basically in today's GFG POTD, we have a problem. Count the number of possible triangles. So basically it is a medium level problem, and as the problem given here, given an integer array R, find the number of triangles that can be formed with three different array elements as the length of three sides of this triangle. And one note is given here, triangles with three given sides is only possible if sum of any two sides is always greater than the third side. So basically in this particular problem, the problem actually asking to us that how much triangles we can actually able to construct it by using uh, if we taking the sum of two sides of the triangle. If the sum of these two sides of triangle is like greater than the third side, then the triangle can be formed, otherwise it cannot be formed. So basically this thing is actually asked in the question. So first of all we are going to check this here by using example. So in the particular example here, if I'm talking about example 1, we have an array with the sizes of elements, or the sizes of we consider sides. Okay, uh, let it will be like 4 centimeter, like 6 centimeter, 3 centimeter, like 7 centimeter, and these are basically the length of the sides. Now we need to like define that within this length how much we can construct the triangles. So as the output given here, like it we can construct it three triangles using this given lengths. Okay, and here the possible lengths are like we consider 3 4 6 4 6 7 3 6 7 and 3 4 7. Actually 3 4 7 is not possible, so only possible is like 3 4 6 4 6 7 and 3 6 7. How we can say here, actually by the questions if we are talking about here, it is all like mentioned here, only two possible if sum of any two sides is always greater than the third side. Okay, so here in this, if I'm going to check here, now if we take the sum of these two particular sides of length, then we can say that 437, which is greater than 6. Okay, so here we actually construct our first triangle. Second triangle is like if we are taking the sum of this 6 and 4, we are actually getting 10, which is greater than 7. So again we got one more triangle, we can construct one more triangle. Okay, 6 3, basically 9, which is greater than 7. So yeah, we can able to construct three triangles by using this sides of length. Okay, and here it is saying that we can't able to construct these things. The reason behind that is if we are taking the sum of 4 and 3, then we actually getting 7, which is like equal to 7. Okay, that means the sum of two sides are actually equals to the third side. So it is not possible, as it is already mentioned in the question, that it must be greater than the third side. It is not saying that it is equal to. Okay, so here is the another example here, like 10 21 22 100, and like these are things. And if you're talking about the third example, like 1 2 3, like here only we have three sides of the length, and if we are going to check the two sides, like let's say 2 plus 1 3, so we are getting the equality conditions here. So it is like very very much important question, and it is like asked in Amazon and Microsoft types of companies. Okay, so it is like really very much important question. And for solving these questions, we have these techniques are like required, like array sorting, data structures, and algorithms. Okay, and if I'm going to talk about the related article, so it is find numbers of triangles possible, and we need to solve this problem with an expected time complexity of order of n square, and expected octave space of order of 1. That means we don't have to use any extra spaces. Okay, so first of all we are going to uh, do what? First of all we are going to sort this array so that we can get the array in the arrange fashion. Okay, so here sort array dot begin, and then array dot end. Now once we perform these things, our arrays are actually getting sorted. That means if you're talking about this particular example here, so here we are actually getting 3 4 6 7, like that. And now we can simply if I'm going through, like if I'm explaining it all about brute force approach here, so we can say that if I'm getting here element like 3 4 6 7 here, so like we can simply traverse it um, by using, let me check, for int I is equal to 0, I is less than array dot size, and then I plus plus. That means by using we can say that three pointers we can say that okay int j is equal to I plus 1 and j is less than array dot size. Like after sorting it, if I am just declaring my three variables, one is placing to the first position, second is placing to the next to it position, and the third is like position to next position, then we can simply check here. Okay, so here let me check. Point I is equal to 0. Okay, j is equal to I plus 1. And if I'm like declaring my third variable, let's say k is equal to, which is next to j plus 1, and if I'm saying that k is like less than array dot size, that means we need to traverse it till the size of an array. And then if I'm saying that k plus plus, now I have declared all those variables with the starting three position. Okay, and now if I'm going to check it here, like if as it is like I've already sorted here, so as I've already sorted my array here, and now to like make a count variable which basically counts that how many type of possible pairs are actually possible to create an to create a triangle. So here first of all we have declared it as a 0, and if I'm saying that if my first side of an array, that means array of I, and the second side of an array, if you're like taking the sum of these two sides of the triangle, or we can say just two sides with length, okay, it if it is like greater than array of k, that means if it's like greater than the third side, then we can simply do what? Here we can just simply do count plus plus. That means yeah, we can able to construct the triangles within this length with this given length. Otherwise we can't able to create it. So if I'm going to check it here, so here return count. Okay, we can simply return our count, and here I'm going to check compile and run. So yeah, here compilation is completed. Let's try to submit it. Yeah, so it is submitted. So basically I've like done this problem with an expected time complexity of order of n cube, as we're using for loop three times. But as the question is expected to solve this questions by using order of n square, so basically for that thing we need to like take two variable, and we need to like place it some at the last positions, and we need to take the sum from the last. And for that thing we need to like taking the condition as I is like greater than or equal to 2. That means we have to check for two lengths, and then after that we have to check that how much we can, that means we have to return how much possibles there through which we can like construct the triangles. So yeah, that's all for today's video. So thanks for watching.